Pensez à bien mettre le micro.
Voilà.
On t'entend bien.
So good afternoon, ladies and gentlemen. I'm pleased to welcome you in this workshop. We are going to begin our presentation. I'm Estelle Desroches, the CEO of CycLife. CycLife is a subsidiary of EDF dealing with the international development of dismantling and radioactive waste management activities. And I will be on that flow with Arne Larsson, coming from CycLife Sweden, and with Fabrice Mousset, coming from EDF direction in charge of French project in dismantling and radioactive waste management. And Fabrice is in charge of the development of a new facility in the French system, the Technocentre. The aim of our presentation is to tell you about sustainable management of contaminated metals from nuclear installation, and we will try to give you an overview of the value brought by a solution put in the market by EDF through CycLife or under development for future needs. So to do that, this presentation will be made in 3 voices. First, a short introduction to remind us the issues or the challenge concerning rad waste management and especially metal management. A second part about the solution used or promoted by EDF. And then we will have some focus to illustrate those solutions. First focus on the CycLife Sweden solution with real case studies, real work undergoing in our facility. And a second zoom around the future Technocentre project. So, as announced, a first slide to set the scene, I would like to say. And to remember us the challenges around rad waste management, and especially the challenge we have to face concerning the management of waste coming from decommissioning projects. As you can see on the figure on the right side of my slide, during that phase of decommissioning, there is a slight increase in terms of production of radioactive waste compared to the other phases of the life cycle of a reactor. So, as we have already shut down more than 200 reactors, and there will be a dozen over in the next decade, we will have a significant increase of rad waste coming from decommissioning operation. And especially metallic waste. To give you some figure, metal from dismantling will represent in the 3 next decades more than 1 million tons in Europe, 50% from France and around 50% from other countries in Europe. So operators and supply chain implied in that solution for managing waste develop a lot of solutions, implement a lot of solutions. The choice of a solution is always a multi-criteria choice. It depends on the constraints you have on your dismantling project. Is there any place to treat waste on site or to dispose them on site? Have you some constraints concerning schedule of the operation? Another point is the availability of solution on site. Is there existing facilities to have a first step or treatment or not? Another key point is the availability and the capacity of final solution repository. A very, very important criteria is the existence of a clearance threshold. Can we imagine recycling in our system? And of course, we have also consideration in terms of cost and financial fix. So, multi-criteria analysis, but what we can notice is that today a lot of work is done to propose what we call sustainable solution in regards to two issues: saving of capacity, of repository capacities, how we can avoid to send a lot of volumes in repositories, and also saving of raw materials, especially when we speak about metals, how we can reuse these metals in our industry. When I speak about that, of course, we all think about recycling solution, and we will speak about that. But in CycLife, we also speak about a way to optimize and to organize our operation on site to avoid to produce more waste from dismantling. For example, to avoid to have unuseful operation on site, to have a facility on site, and to have a way to mutualize facilities. It's a way to avoid to produce more waste through this treatment operation. So in that context, as I say, EDF Group has decided to develop, to promote, to use solution with that sustainable approach. We called it a waste-led decommissioning approach. And it is especially done through CycLife activities. On the map of the slide, you can see all the current activities of CycLife. Well, it's difficult to read, I think, but we have 3 nuclear sites in UK, in France, and in Sweden, with a large scope of treatment solution, large component treatment, cutting, melting, incineration, pyrolysis, and recycling, with the aim to reduce the volume of waste and to recycle a maximum of raw materials. So 3 nuclear sites, but you have also 3 engineering and expertise center with very high skill to develop and design workshops, platforms, tools, essentially remote tools to design the scenario of dismantling with that aim to avoid unuseful operation on site and to have this complete way to imagine dismantling plus waste management. And it's that combination of skills which is our model and which allow a systemic approach of dismantling plus waste decommissioning, and that allow to reduce interfaces and to also to optimize schedules and of course to reduce final waste volumes. Just an illustration through a concrete example, the large component management. The solution which is provided by CycLife is to avoid cutting on site and to transport very large pieces, if it's possible, to have a transport in one piece. As I said, it's allowed to reduce the number of operation on site, to shorten the decommissioning schedule. And we combine that with a treatment on our facility, which allow to cut, to treat through a mechanical or a chemical treatment, and then to melt large components. So with a very big reduction of volume, up to 95% of reduction, and also a very high rate of recycling, more than 80%. In France, recycling is done in the nuclear industry because we have no clearance threshold. We hope to have it in a few years, and Fabrice will tell you about that. But in Sweden and UK, we use that possibility to recycle a lot of metals as an economy in raw materials use. So now I let the floor to Arne, who will present you concrete cases of treatment in Cyclife Sweden facility.
Thank you, Estelle. It's really a pleasure to be here and to have the possibility to tell you about what we are doing in our Swedish operations. I will give you the history first. We started in the mid-1970s, started with incineration in our facilities. And in the middle of the 1980s, we started with metal treatment. Already after a few years from startup, we started to provide services also to international customers. The services to international customers is based on the principle that all treatment is performed in an isolated campaign, which allows that the radioactivity imported together with the material is returned to the country of origin. That means that we never will send any German nuclides to United Kingdom, etc. That's a very much a basic principle of our operations. I will give you a tour of what we are doing. And if we start with an overview of the operations, the biggest part in the Cyclife Sweden operations is the metal treatment. We have today a capacity to treat up to 5,000 tons a year, and in the future that will expand further. And the metal treatment operations, they could involve metal melting prior to clearance, but it could also be decontamination and free release measurements. The overall objective is to recycle as much of the metal out to the conventional industry in a safe way to minimize the amount of waste for disposal as radioactive waste, and to provide the conventional industry with good material. The second part is the incineration. That is incineration of organic waste. It could be dry waste, paper, textiles, plastics, wood, etc. But it could also be different types of oils, water solutions from decontamination containing some agents, etc., which is not suitable for disposal. And then we have a small second thermal treatment process for organic waste, and that is dedicated to the fuel factories, the fuel factory in Sweden, where we treat uranium-contaminated organic waste in a pyrolysis unit to allow that we can leach out the uranium from the ashes and put them back into the manufacturing of nuclear fuel, to have a circular approach there. We are doing compaction services also for such material, mainly metals, which are not possible to treat for clearance, but we can reduce the volume as much as possible to reduce the customer costs. As was said by Estelle before, clearance is a key in our operations. So we are doing clearance for recycling back to the conventional industry. And it's done in a safe way, respecting all rules. We follow the European directives as well as the European recommendations on that. And currently we have customers in 14 European countries, and we hope to get some other international deliveries of material for treatment the coming years. We are also doing cable recovery. We know, especially in decommissioning, but also in power upgrades, there are large volumes of cables in installations. But proper treatment, close to 100% of the metal in the cables can be recycled to make new products. Our Swedish operations also is responsible for the non-nuclear waste from the Swedish industry, hospitals, research, etc. So that is also something that we manage within Sweden. And of course we have our own our laboratory to make all the measurements needed. To provide you with an example of how a treatment concept could look like, this is for large components, in this case steam generators, where we are able to provide a door-to-door solution. That means that we pick up a component at the nuclear power plant for a quick removal, so the commissioning or power upgrade can continue without any delays. And we take it to our facility, we do the treatment, we do the recycling of the metal, we pack the residual waste into containers which fits into the disposal system in country of origin, and we ship it back to our customers. And those treatment operations contains different parts. Of course, transport is a big part. We're doing cutting. It could be cold cutting using a bandsaw. It could be hot cutting using a torch. Decontamination is key in this. And of course, the melting to get a very representative sample for the later clearance process. As said in the beginning, we are doing two types of metal treatment services. We have one route for decontamination and direct clearance, and we have one route where we do decontamination and melting prior clearance. And this is good because a lot of the metals coming from a decommissioning or power upgrade project is potentially contaminated. And then it's a bit waste of resources to do the full cycle with melting. Then you do the decontamination and the clearance in the dedicated equipment. While for other material, you do the melting. And to illustrate the differences is that it's much harder to reach the goal when you do direct clearance compared to when you do melting. That means that we properly have to select a route, and we also can diversify the material after arrival into the different routes. In the facility, we can welcome large components up to 30 meters long and with a weight of 400 tons. I will now provide you with a few case studies. We are starting in the UK. Some years back, we received 15 Magnox boilers. That's a steam generator on the UK design reactor. Each boiler had a volume of about 600 tons at delivery. And after our treatment, it was reduced to 8 cubic meters of waste for return. So a reduction factor, so only a little bit more than 1% of the material had to go to disposal. The rest of the material could be subject to clearance and recycling back to the industry. The second case study is regarding steam generators coming from the nuclear power plant Ringhals on the Swedish west coast. In total, we have treated 9 steam generators from that facility. We have done size reduction and management of the tube bundle, which is highly active, to minimize the volume of that for a safe disposal. And the rest of the components have been treated, aiming for clearance and recycling in a successful way. Thanks to those demonstration projects, we have recently signed contracts for more than 20 steam generators for treatment in this Swedish facility the coming decade. So it's very, very good. The third case study relates to boiling water reactors. And here we can see a turbine rotor from one of the Swedish facilities. For one upgrade project, we received more than 1,000 tons of turbine island components, heat exchangers, turbines, valves, pipes, etc. And we got a fantastic result. Less than 5% of the initial mass became waste for disposal. The other 95% was recycled, safely recycled. That was all for me, so I give the word to Fabrice.
Thank you, Arne. So as said, Estelle, the French volume of very low-level waste is about 50% of the European volume in the 3 next decades. And so EDF and Orano are considering the creation of a centralized installation in France for recycling this volume. And this volume is made by first mainly the steam generators of the nuclear plant of EDF, and also by the diffuser of the factory of Georgia-based 1, with it's increasing in uranium, and the whole factory has to be dismantled, and it's about 50% of the French volume. The law in France is ongoing, and the evolution is ongoing, and we expect that the French decree will be okay by the end of this year. The State Council has regarded the decree last week, so we always expect by the end of the year. And the installation in France will be able to treat 2 kind of metallic materials. First, the French ones, but also the materials can come from other countries in Europe or all over in the world. And as said, Arno, this factory will be able to decontaminate, to dismantle the large component as steam generators, to put them in a furnace to melt, and to produce ingots which we could be sold in the conventional industry as any metallic ingots made by raw. And the volume of scraps will be treated in the furnace is about 50%, and steam generator 50%. And you have to keep in mind that recycling 1 ton of steel is saving up to 20% of energy consumption, and reduce footprint by carbon footprint by more than 60%. And the project is to have an installation about in 2031.
So just a few words to conclude. This last slide summarizes what we present. Back-end decommissioning plus waste management is a major step for nuclear sustainability. If we want to conceive and construct new reactors, we need to demonstrate that we are able to close the cycle of our nuclear facilities. It's a question of acceptability. We will have to face, as we said, a significant increase of quantities of food waste coming from decommissioning, but sustainable solutions exist or are under development to face with challenge. And we hope that we provide you some ideas and to see how we can do that from dismantling to waste treatment in a sustainable way. And we are ready to answer your question, I think, in the networking room, if you have it. Thank you.